In this video, we will learn about molecular arrangement in matter, three states of matter. Matter can exist in any three states, that is solid, liquid or gas. The properties of three states of matter can be explained on the basis of molecular arrangement in the three states. First is solid. The molecules in solid are closely packed and the intermolecular spaces are extremely small. We can observe over here. So this is the molecular arrangement in case of solid. We can observe that molecules are very closely packed with very little intermolecular spaces between them. Since molecules are very close to each other in solids, intermolecular forces are very strong and hence position of molecules are fixed. As a result, solid has definite volume and shape. In solid, molecules can have only vibrational motion because they do not have enough space for rotational or translatory motion. A solid cannot be compressed on account of close packing of molecule. Thus, solids are hard and rigid. Since molecules of solid have very less intermolecular space, they cannot be compressed, because of which solids are hard and rigid. And because of same reason, a solid cannot even flow and hence it can be stored independently without a vessel. The next state of matter is liquid. The molecules in liquids are less tightly packed or the intermolecular spaces is somewhat more than that in solids. Here we can observe these are the molecules of liquid and they have some intermolecular space between them. So as compared to solid, they have more intermolecular space, because of which intermolecular forces are weak and hence position of molecules is not fixed. Thus we can say that liquid has no shape of its own and hence it flows. But these molecular forces are enough to not allow the molecules to leave the liquid easily, so a liquid has definite volume though it does not have a definite shape. Liquid have some molecular space, that's the reason it can be compressed, but it can be compressed only a little. A liquid can be stored in a container and a liquid has a definite free surface. Next, on heating, the vibrational kinetic energy of the molecules of solid increases and so the intermolecular distance increases. And at a particular temperature, the solid will melt and change into liquid. So on heating, the kinetic energy of liquid molecule is going to further increase and the intermolecular distance is going to increase furthermore. And at a particular temperature, the liquid will boil and change into gas. So we can say that on heating, solid can change into liquid, and on heating furthermore, liquid can change into gas. Here we have an activity to show that liquids have intermolecular spaces. Materials required are a glass, a table, sugar, and water. Let's understand the procedure. Take a glass and put it on the table, fill it with water up to the brim. Now add small quantity of powdered sugar or salt carefully to the glass. What do you observe? We observe that the sugar is dissolved in water and water does not spill over. You may gradually add more sugar to the water, and this clearly shows that water has intermolecular spaces and sugar molecules have entered into these spaces. Otherwise, the water would have spilled. But since water has intermolecular spaces, the powdered sugar or salt that we are putting is going to enter into these space and hence the water is not spilling. So from this activity, we can conclude that water has intermolecular spaces and water is a liquid, so we can say that liquids have intermolecular spaces. Moving ahead, we have the next state of matter, gases. The molecules in gases are far apart or the intermolecular space is much larger than liquids or solids. Hence, the intermolecular forces are extremely weak or almost zero. Here we can observe the molecular arrangement in gases. So these are the molecules which are far apart from each other, and since they are far apart, the intermolecular forces between them is going to be extremely weak, or it is going to be almost zero. That's the reason in a gas each molecule moves independently, and therefore a gas has neither a definite shape nor a definite volume. It can be stored in closed vessel only. And since it has more intermolecular spaces, a gas can be compressed easily. A gas can also flow very easily. Moreover, a gas has no free surface of its own. Moving ahead, we have a table that shows differences between solids, liquids, and gases on the basis of the molecular concept. So here we have solids, liquids, and gases. The molecules are closely packed and intermolecular spaces are extremely small in the case of solid, but in the case of liquids, the molecules are less tightly packed and the intermolecular spaces are more than that in solids. Next, we have gases. In gases, there is no packing amongst the molecules and intermolecular space is very large. Next is the intermolecular forces are very strong in solids, but in the case of liquids, the intermolecular forces are weak, and in the case of gases, the intermolecular forces are almost zero. Next is position of molecules. Position of molecules in solid are fixed and a solid has finite shape and size. Whereas in liquids, position of molecules are not fixed and hence they have no finite shape but they have finite volume. Talking about gases, molecules are moving independently and hence gases have no shape or volume of their own. Next, molecules can have only vibrational motion in case of solids, but in liquids, molecules can move inside the liquid but cannot leave the liquid surface. But in the case of gases, molecules are having random translational motion and they are moving independently of each other. Next is solids cannot be compressed, whereas liquids may be slightly compressed, but gases can be compressed easily. I hope this topic is clear to you. Thank you.